Okay, in this video I'm going to talk about inverse functions. And so these are functions that undo a function, in a sense. So let's take a look at this. The function f of x is invertible if and only if it is a one-to-one, right? A function is one-to-one if for each y there is only one x such that f of x equals y. Usually this is thought of as the horizontal line test. So the horizontal line test is kind of pictured here. So our idea is we have a function like this guy, and if we can draw a horizontal line at every point and it doesn't intersect any other point on the curve, then it passes the horizontal line test. If we have a curve where we can draw a horizontal line at one point and it touches the curve more than once, then it fails the horizontal line test and it fails to be invertible, okay? If f of x is invertible, we denote its inverse as f inverse of x, so f to the minus 1 of x, we call that f inverse of x. And it has the following properties. F inverse of f of x is x. F of f inverse of x is x. So if I compose f with its inverse, it's always x. Further, if f of a equals b, then f inverse of b equals a. Okay, so we swap x and y basically, right? So if f of x equals y, then, right, so let's look at this. If f of x equals y, then f inverse of y equals x. We'll use this later. And f inverse of x does not equal 1 over f of x. So you might be tempted, you see the -1 in the exponent there, you might be tempted to look at it as 1 over f of x, but it's just not. The graph of f inverse of x is the same as the graph of f of x, but it's just reflected across the line y equals x. You can see that here. Okay. And the domain of f is the range of f inverse and vice versa. Okay. So let's determine if the following functions are invertible using the horizontal line test. So that requires knowledge of being able to graph them. So if you don't know how to graph functions, take a look back at my video on that. But let's take a look at these. So f of x equals x plus 1 squared minus 3. So that's just the same as the graph of f of x equals x squared, but shifted to the left 1 unit and down 3 units. So to the left 1 unit, down 3 units. That looks like this. And I can draw a horizontal line here, really anywhere except for here, and it'll touch the curve at more than one point, so this is not invertible. Okay. G of x equals x cubed plus 7. That's just the graph of x cubed, but shifted up 7 units, so it looks something like this. And no matter where I draw a horizontal line, it passes the horizontal line test, so this is invertible. H of x equals 2 square root of 5x minus 1. So let's draw that. That is just the graph of the square root of x shifted right 1 unit, horizontally compressed by a factor of 5, and stretched by a factor of 2. In any case, it looks something like this. And I can draw a horizontal line at every point, and it won't touch more than once. So this is invertible. Okay. And let's take a look at k of x. K of x is 1/7 x plus 3 in absolute value minus 1. That's just the graph of absolute value of x, horizontally shifted by 3 units to the left, down 1, and then compressed by a factor of 7. So it looks something like this. And it does not pass the horizontal line test. So this is not invertible. Okay, so let's find some inverses. We want to find the inverses of the following by letting y equal f of x, then swapping y and x. So let's take a look at this. So we just replace, our steps are replace f of x with y. So y equals x plus 1/3 cubed plus 1. And then we swap x and y. So x equals y plus 1/3 cubed plus 1. So we're using the fact that if f of x equals y, then f inverse of x equals, f inverse of y equals x. This will allow us to solve for f inverse of x in terms of y. So if we solve this second equation where we swap y and x, we'll get f inverse of x as y. So now what we got to do is solve for y. So I can subtract 1 from both sides, so x minus 1 equals y plus 1/3 cubed. I can then take the cube root of both sides, so the cube root of x minus 1 equals y plus 1 over 3. And then I can subtract 1 over 3 from both sides, and I'll go ahead and swap this around here to get y is the cube root of x minus 1 minus 1/3. And this is f inverse of x now. So f inverse of x equals the cube root of x minus 1 minus 1/3. Great. Okay, moving on. G of x equals negative 7 times the square root of x plus 4. So that is, all I need to do is write g of x is equal to y, square root of x plus 4, and just swap x and y. So x equals negative 7 square roots of y plus 4. I can divide both sides by negative 7 and get x, negative x over 7 equals the square root of y plus 4. I can square both sides and have that y plus 4 is equal to x squared over 49. And then I can subtract 4 from both sides to get that y is equal to x squared over 49 minus 4. And that is f inverse of x because we solved for y. F inverse of x equals x squared over 49 minus 4. Okay. And then our last example, h of x is equal to 1 over 19 x cubed plus 3 minus 1/3. Okay, let's take a look at this. So I need to write y equals 1 over 19 x cubed plus 3 minus 1 over 3, and then swap x and y. So I have x equals 1 over 19 times y cubed plus 3 minus 1/3. So how about I just add 1/3 to both sides? So x plus 1 over 3 equals 1 over 19 times y cubed plus 3. And then how about I multiply both sides by y cubed plus 3 to cancel that y cubed plus 3 in the denominator. So I have y cubed plus 3 times x plus 1 over 3 equals 1 over 19. And then I'll just go ahead and divide both sides by x plus 1/3. So y cubed plus 3 equals 1 over 19 times x plus 1 over 3. And then I can subtract 3 from both sides. Y cubed is equal to 1 over 19 times x plus 1 over 3 minus 3. And then take the cube root of both sides. So y equals the cube root of 1 over 19 times x plus 1 over 3 minus 3. And I would accept it this way. And this is f inverse of x, now that we've solved for y. F inverse of x. 1 over 19 x plus 1 over 3 minus 3. All done. Okay, and that wraps up what I have to say about inverse functions. If you found this video helpful, please consider liking and subscribing. Thanks.